If you watched my previous video on the destructuring assignment, you will notice that I used a very strange syntax to render my string literals. That is template literals, and we shall be going over it in this video. My name is Kelvin, and my goal is to help you go through technical documentations so that you may have an understanding of the tools that you're working with. If you're new here, don't forget to like this video, subscribe to this channel, and leave a comment below. In case we mention any link in this video, you can find it in the description section. Let us dive right in. Before we dive in to look at the syntax of template literals, let us take some few minutes to appreciate how we used to work with strings before ES6. So when it comes to wrapping string literals, we either used to use single quotation marks or double quotation marks. So if we change this to double quotation marks, you can see that nothing changes. One of the challenges that came in when working with either single quotation marks or double quotation marks is when these characters were included as part of the string. For instance, if we have the string hello world and we wanted to include another double quote within the string, you can see that it breaks the syntax. But we fixed this issue easily by using the backslash. Vice versa, if we are working with single quotation marks and we have a single quotation mark within the string, we had to use the backslash to escape that and include it as part of the string. But if you had a double quotation mark in a string wrapped with single quotation, it works with no issue, and vice versa. With the introduction of template literals, we basically use the backtick to denote a string literal. And you can see that nothing is really changing in my console.log. I'm getting the same string logged, the same length, and the type of the variable is string. But there are some cool things that you can do easily with template literals that were a pain to deal with while using single quotation marks or double quotation mark. The first one is declaring a multiline string. Let us look at an example using a double quotation example where we want to declare a multiline string. So I will say hello world, second string, then third string. In order for us to separate this into multiple lines, we had to use the new line character as stroke n. Second string, then backslash, then n. And you can see in my console, I am getting multi-line string. It might not be readable when looking at the code, but with the introduction of template literals, we can separate this string into separate lines and it will be interpreted as a multi-line string. So by simply converting this to a template literal, then having the string on new lines, you can see that it is printing out the string in new lines. This is very easy to read and understand compared to seeing backslash and the new line character in a single line. You might not know what is going on. Another powerful thing that comes with using template literals is what we refer to as string interpolation. Basically, we are able to pass in variables and even expressions dynamically into a string. An example would be 1 plus 2. And I can have an expression, so 1 plus 2, and you can see that it is printing out the results for me. That is really cool. We can even have a variable, so and I can have pass in that variable. 1 plus 2 is 3. That is very easy to read and very easy to understand. But before the introduction of template literals, we could still do the same operations, but we had to use the plus sign to pass in variables in a string. An example would be So we have hi, then instead of the interpolation signs, we will close the string, then have a plus sign. I'm actually getting tired just thinking about what we used to do back in the days. Then we would close the string and have a plus sign. Okay. Yeah, we could achieve the same result, but it is very hard to read. And also you can miss where the plus sign is starting and where the plus sign is stopping. A good example will be where we are performing the arithmetics. It's very hard to read. Maybe just to point out one more thing is you can literally pass in anything here as long as it is a JavaScript expression, even a function can be passed here. So a good example would be I will write a function called sum that accepts the two values 1 and 2. And I'll have a function called sum which returns the sum of those two values. Oops. And you can see that we are getting the same result. So whenever you have an opportunity to use template literals, you can actually take advantage of this new feature. One final thing that we shall look at is tagged templates. And what does that mean? You can think of it as a transformer method that can be attached in front of a template literal. A good example would be, let's say I have, so just say tag, which is a function. Then immediately after that function, we can have template literals. So I'll say hi. Maybe let me pass in greet. Let name, we assign it to Kelvin. Then we can interpolate my name into the string. So basically a tag template is a function that transforms the template literals or the contents of the template literals. So in this case, we can define a function called tag, which accepts two parameters. The first parameter, or has two parameters. The first parameter are the literals, which is an array. And then you can basically access all the parameters that are passed as an array of the substitution. So any dynamic content will be in the second array. Hope my spelling is correct. Let us console log the results so that you can see what is going on. Literals, then substitutions. And you can see that we are getting two arrays. So the first array is the array of the static strings. So in this case, we have hi, then empty string. And then the second array is actually the array of the dynamic content. And in this case, Kelvin is. So we are able to transform that string. We can use the reduce function. So literals dot reduce, since it's an array, and we can have previous, then current. We can also get the index, and we can return previous string, then connect it to the current string, then finally substitute in the values. Substitution, then the index. We need to have an empty string here. Let us see what is going on. Then pass in greet. Undefined, or an empty string. So you can see that I'm able to generate a new string based on the literals that are passed in to the tag function. Hi, Kelvin. So you might ask yourself, what are some of the use cases for this? And one of the things that I've been able to find it might be useful when it comes to localization of the text. And I wrote a simple example just to show you the power of this feature. So instead of tag, I can actually change this to I18N. And I can move this to create some space. Then we can have an object of languages. So basically an object of languages, a translation rather. So hi in English, hi in French, hi in German, and I don't know what that is. I just copy pasted it from the internet. We are able to declare a default language. Default lang. Let us start with English. And instead of passing in current, we can translate that string. So we have lang, then get the default lang, then translate it. If it is there, it is not there, we pass in an empty string. We also need to trim this just in case. I think let us get rid of the question mark just to simplify things. Hi Kelvin, and that works. Awesome. Let's just add some bit of space. So hi Kelvin, you can see we're already getting something. We can also change this to French. Bonjour Kelvin. Yeah, and that is one of the use cases or application of tagged templates. You can take advantage of it. I know probably there are some certain libraries that have already been written that take advantage of this. So you can also take advantage of it. If you have found value in this video, don't forget to like, subscribe, and share this video. Thank you, and see you in the next one.